Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
All right. Thanks for doing this, sir. Appreciate it.
Oh, you're welcome.
I've enjoyed many of your videos online, so I'm fascinated by these theories that you have. And so
that's one.
so I'm excited. I'm excited that you're here. Could you please, first of all, could you just tell everybody what your background is? Like, what did you start off doing professionally?
I started as an apprentice in a engineering company in Manchester, England, and worked through the apprenticeship. Received my journeyman papers, worked for a couple more years in England, and then I was recruited by an aerospace company in America and emigrated to America.
And what did you do for this aerospace company?
Well, I started out as a lathe turner. That was my specialty. So,
A what?
A lathe turner?
A lathe turner.
Yeah.
Yeah.
Right, so I was a lathe hand, right?
Mm-hmm.
So I operated, horizontal lathes, vertical lathes. In England, they had what they call them vertical boring mills. And in the States, you have to learn a different language, right? They have the cultural differences between, right? So you pick up different terminologies for things. Like they call it a vertical turret lathe. In England, they call it a vertical boring mill.
Mm. And so you're working with machines, and when did you come up with this theory about the pyramid?
Well, actually, I had been in the States for a while. It was I came over in 1969, and in 1977, I picked up Peter Tompkins' book, Secrets of the Great Pyramid, and I started to examine that book. And one of the things that Tompkins, he asked a very significant question in that book, and he said, does the Great Pyramid enshrine a lost science? Is the Great Pyramid a product of that science? Does it reflect that science? And I took that question very seriously, and that question was in my mind as I read through the book. And then I started to explore some of the references that he provided in the bibliography. One of them was the work of William Flinders Petri. And he described lathes being used in ancient Egypt. He described very large coring drills up to 18 inches in diameter. And he also claimed that they were using circular saws.
When he's describing this, like what kind of metal would they be using?
Well, that's the thing. The question really demands that you explore all methods that you are able to, when you satisfy the historical record, say the archaeological record, and you say, okay, I'm going to try this. Well, that's not going to work. That won't work. So we'll try this. We'll keep improving our methods and tools until we arrive at a solution to explaining the artifact. Mm-hmm. That's the important thing. That's basically the demands on a manufacturing engineer, which I eventually became. So, if a customer comes in and they bring a part to the company and says, I want you to make one just like this. What do we do? Well, we have to know what this is. And to do that, you take measurements, you determine materials, how it was manufactured, you look for tool marks to see what processes may have been involved in it, whether there were dies, whether there's machining marks in areas. You look at the welds. Did they weld some parts? Did they braze other parts? And then, of course, the geometries. And basically, that's your model. That's like, okay, I've got to make something just like this.
Right, but when you're making some, like, if you're looking at, say, some of the stonework that was done in the pyramid, where there's, not in the pyramid, but in some of the quarries, where you see these core drill holes,
Right.
like, how would you reverse engineer that? Like, how would you figure out what could possibly do that?
Well, that's the interesting question. And it's one that's been a huge debate going on about that, and it really goes back to 1984. And I had published an article called "Advanced Machining in Ancient Egypt?" ? And it was published in Analog Science Fiction Science Fact magazine in August of 1984.
So you've been at this a long time.
Is that before you were born?
I was in high school.
Yeah, you were. Right?
Yeah, I was a junior in high school.
I wasn't. So it was, and Stanley Schmidt, Dr. Stanley Schmidt, who's the editor of Analog, very respected editor, selected it for publication. And we went through, the editorial processes, suggested changes and stuff like that, and then it went out.
And so, what did you, when you look at like the core, the drill holes, the vases are another like very fascinating and real gigantic mystery as to how those were constructed, and we'll talk about those as well.
You
is
mean this?
that what it looks like? That's a model of one.
Yeah.
But the core holes itself, we had a debate recently with Graham Hancock and Flint Dibble, and one of the things that Dibble had suggested was that they had done something with sand, and that was how they were able to do this, with copper and sand, and they were able to drill. Does that make sense to you?
Well, I mean, I've heard that theory about how they were done, and I know that there has been work done to prove that theory is the correct one. But central to explaining at the actual core, if you go back and you read Petri, he described a spiral groove around a granite core, and he said that it had a pitch of 100 thousandths per revolution of the drill. And so that's what I was going on when I claimed, well, what kind of a process would you need to...
Can I stop you there? When you say a pitch of 1,000th per...
Yeah, for every revolution of the drill, it sinks into the granite 100 thousandths of an inch.
Okay, so because of that, you know that this thing has to be operating at a certain speed?
Not necessarily rotational speed, but the penetration rate.
So with each rotation, it will go how long? How far?
100 thousandths of an inch, which is almost 1/8 of an inch.
So that's pretty impressive when you're talking about solid granite, correct?
Yeah.
And that probably wouldn't be possible with copper and sand.
No.
It seems like
No.
Sand and copper just are not abrasive enough.
No, I contacted a company that specialized in drilling granite, and I asked them what is the feed rate. That 100 thousandths of an inch would be the feed rate of the drill. What is the feed rate of your drills when you're drilling into granite? And I got a response from him, and he said, generally, our drills, they're diamond. They rotate around 900 revolutions per minute, and the penetration rate is about 0.2 of an inch per revolution. So 0.2 thousandths of an inch per revolution.
Oh, 2/10,000.
2/10,000. I'm sorry, I misspoke. Yeah. So 2/10 thousandths of an inch is like 500 times smaller than 100 thousandths of an inch.
Wow. So these drills that they used in Egypt were capable of drilling, with each revolution, 500 times more than modern diamond drills that were used by people who cut into granite.
their penetration rate
Yeah.
was 500 times greater.
So it might have been operating at a slower revolution, but when it's going through its full revolution, it's
Right.
much more effective.
That's what I concluded in
Now,
the
is this
article.
but is this in multiple different drill holes, or is it one individual sample that they found that seems to operate at this depth per revolution?
There have been inspections on several different cores,
And have they all yielded similar results?
and they have all revealed that the groove is a spiral. In other words, it's a continuous spiral around the core. The most recent examination of those cores was in 2018 by two aerospace engineers, Eric Wilson and Josh Gear, and they asked the Petri Museum in London permission to examine the cores in their collection, the Petri core number 7, which is the most famous core, and the one that has drawn the most heated kind of debate about.
Can we see what that looks like? Jimmy, can you find that one? Petri core number 7.
It's on that, yeah.
Because this, to me, and the vases, obviously, and of course the construction, the pyramid itself.
Right,
They're also the symmetry of the faces.
right.
There's so many things that are so mind-blowing about whatever they did and how they did it. I mean, forget about all the mysteries.
Right.
Just what we know in terms of, okay, so these are these two core samples. These are these two cores.
They're the same one. And they're from Lost Technologies of Ancient Egypt. And essentially, what happened was there was a book written, I think it was in 1999. It was by Chris Ogilvie-Harold and Ian Lawson, and it's called Giza the Truth. And so what they did is they had associates that went into the Petri Museum and examined the core to see if it was actually a spiral. So they took photographs of it, and they examined those photographs, and they said, no, they're horizontal. Now, there's a big difference when you talk about a horizontal groove
Right.
and a spiral groove. And so I was like, okay, I suspend all assertions as far as the methods that I proposed for how it may have been done. I need to go and examine that item myself. And so I booked a flight to England, and a friend of mine in Cambridge picked me up at the airport, Nick Annis, and we went to the Petri Museum, and I examined the core. The method I used was to just wrap a simple cotton thread around it.
So you just followed the groove with the thread.
With the thread. But I was wearing...
rubber gloves?
Well, yes, I was wearing rubber gloves, but I was also wearing a visor with lenses in it that gave 10 times power.
Oh, okay,
10
so you
times
could
power.
really see where the grooves are?
Yeah, you would find those items in any tool maker's box.
So
right?
if the lines were horizontal, you would go around in a circle, then you'd have to cross over the ridge to hit to the next circle.
Yeah.
But in this case, it was continuous.
No, I mean, it was continuous.
Right.
Okay.
So how did they miss that? That seems like this is such an important piece of history, such a fascinating thing to examine. Look at this mystery. You have this granite core.
Right.
How do they do it? There's lines on it.
Right.
Are they horizontal or are they a spiral?
Right.
And then they just go, oh, it's horizontal. And then you come along with string, and you're
Right.
like, no, it's a spiral.
Right.
Like, how does someone screw that up?
Yes, I mean, they would say that I screwed it up, obviously. But the thing is, Joe, is that, when you're conducting research, anybody, whether you're a scientist or just a, Joe
Yeah.
Blow in the tool room, and you say, okay, this is what I found, and these are the methods I used, and these are the results, okay?
Right.
So you set you describe your experiment, you lay it out, and you explain in detail how you did it.
Wouldn't with today's technology, wouldn't it be really easy to scan it?
Well, it is now, yeah.
Yeah,
Obviously.
and then they would. So have they done that? Have they definitively proven one way or the other?
I don't think there is a really high-quality scan that would be necessary. I mean, I've learned a little bit about scanning. It was just being introduced into manufacturing when I retired, just before I retired. We started to look into it, and we bought this white light scanning system. But now...
the systems now are so advanced.
The systems now
and you
are
feed
like
it through
light
AI,
years ahead.
and you would feed it through AI, and it would tell you exactly.
Well, I mean, you basically you could slice it, dice it, examine it any way you wish, but you need to have qualified people to do it. Not anybody with that's not qualified could examine that.
Right. So either way, these cores and those drill holes represent something sensational, something absolutely amazing. Some 4,500-year-old drill that somehow or another was more effective than drills that are being used today.
Yeah, but you know the truth of the matter, though, Joe.
What?
It's probably.
I wish you could just tell me, and then we'd know. There's so many mysteries.
It's probably the most insignificant artifact I've looked at.
I'm sure.
I mean,
you've looked at so much in Egypt.
Yeah.
I mean, but to me, it's like a corner piece.
Oh, people are freaking out over it.
Yeah.
How could you? How dare you?
Well, I'm sure, because it throws everything into flux. Because how did they? The assumption is they did this through intense labor over long periods of time, and it took forever to do.
Right.
And if they're operating at a pace that's 500 times more effective than a drill that's used by a modern... Have you talked to other people that go into granite? Are there more sophisticated drills that work better, or more powerful drills that work better than his?
The thing is in manufacturing, and this is a fact. You don't know the full scope of what engineers are capable of doing.
Right.
Because you're not in every shop in every country in every town in the world, and so nobody knows exactly what all engineers are capable of. There may be somebody actually reproducing the features on that course somewhere using some method.
Right.
I don't know. You just don't know.
But from the person that you talk to that does it professionally, that uses high-level equipment, his drill was 500 times less effective.
It was the feed rate was less. The revolution could have been more. I mean,
Right.
You said it earlier. You said could it have been rotating slowly?
Right.
It didn't have to spin very fast. In fact, it's better when you're machining hard material or grinding hard material, is that you don't.
Why
because heat is the biggest enemy of a tool.
Oh, that makes sense. Yeah, that makes sense.
Yeah.
Yeah. Okay. So, what do you think, if you had to guess, that they were using?
I actually created my own core just to experiment, right? And I learned a lot doing it. I didn't use the same method as some of the other researchers that are out there that did it. I had a copper tube, and I had corundum.
What's corundum?
Oh, it's a very, very hard grit that you use to grind into hard material.
So the copper tube would be flat at the bottom, and then you'd put the grit in. The grit would act as...
Right. And so you'd rotate it, rotate it. And, I set up a jig and a tube and just ground it, just so that I could see the results of that. For one thing, they say that copper was the only metal that was available to the ancient Egyptians, but when it came to knocking out the core from the hole, I tried copper, and it wouldn't budge it, so I had to use a steel chisel.
Is it possible that they use something else, like heat?
You know, I'm actually leaning more towards that because of the difference in the finish.
Like if they poured boiling water in it or something, would that loosen things?
I don't think water would be it, but if you compare
the difference in the finish. I'm sorry. What did you mean by that?
Yeah, that I don't think has been discussed enough or recognized to be important enough. Is that when you use an abrasive like sand or like emery or anything to grind out a hole or do whatever, you leave a sanded finish naturally.
Polished.
Not polished.
Sanded.
No, sanded.
Smoother? Is that what you mean?
It could be smooth, but it's
Right.
definitely got a sanded finish.
And what is the difference between a sanded finish and the finish of a diamond bit?
Well, we don't know if they were using the diamond bit, but that's
But I
the
mean,
other
but that's
thing.
what they do today, right?
That's what they do today.
So what is the difference between a sanded finish?
Well, you still have the same thing. You're using an abrasive.
Right.
You're keeping the abrasive as cool as possible as you're grinding away, but you're still grinding it, and so your finish is not going to be polished unless you have a secondary process where you go in and polish it with a finer grit. You don't start with the very, very fine grit because you won't get anywhere with it.
Let's take a look at some of those holes. Jamie, can you show us some of those holes, the drill holes in granite in ancient Egypt? So here we could see right here, which is absolutely wild. Some of these
Yeah.
images, I mean, that is absolutely wild.
Right.
I mean, how the hell did they do that?
Well, that's what just about. This is like an engineer's playground over there. They go through there.
Right, and as an engineer, you must be just like scratching your head.
Yeah. Yes.
Fascinating
definitely.
stuff.
Yeah, definitely.
Jamie, click on that. Well, yeah, there we go. That's a good one. I mean, that one's wild. That is just absolutely crazy.
That is at. Looks like it's at Abu Ghraib, and it's in an alabaster.
Have you ever measured the circumference of these things?
No.
Have you measured
No.
the diameters? Have you measured whether or not they're equal circles?
Well, they are definitely round. For
They're
sure.
perfect?
Yeah.
Perfectly round?
I wouldn't say perfect. No.
So absolutely
there's
a
no
drill
su-
was used.
You can't say perfect
Right,
in this
right, right.
day and
Of
age.
course.
There's no such thing as perfect.
Right. But
But they're round.
close enough too. And so these wow, look at that. That is amazing. So these circular holes were definitely cut by some kind of a drill. That's agreed upon?
Yeah.
Okay.
Yeah.
So if you couldn't do it with the copper, like when you tried to do it with copper, how long did it take and how much results did you get? Look at those circular marks, man. That is crazy.
There's a few days.
That spiral right there is absolutely nuts.
Mhm.
I mean, it just clearly looks like a drill hole.
Yeah, I think that's my photograph, actually.
Is it?
I took that one.
So how long did it take you to drill a hole?
Probably a day and a half, 2 days.
Day and a half,
Something
2
like
days, and how deep was the hole?
The hole was probably 2 inches, 2.5 inches deep.
Well, that seems like it's doable then, right? If you could just keep doing it day after day, week after week, you'd get a big core.
Yeah, and and that's basically the what everybody concludes. The Egyptologists will conclude that they had all the time in the world to do these things.
But wasn't the Pyramid of Giza, the Great Pyramid, wasn't that supposed to be completed inside of 30 years? Isn't that the hypothesis?
I've heard anything between 10 years and 100 years. So,
Yeah.
yeah. Nobody knows.
They don't. It's just guesswork, right?
Yeah,
I mean, there's what is it, 2,300,000 stones,
right.
and the heaviest ones in the base. Like, what are the heaviest ones?
Well, the ones that we know of in the Great Pyramid weigh up to 70 tons, and those are the
In the King's Chamber?
the granite ones in the King's Chamber. Yeah.
So there's that. There's the drill holes, which are just absolutely fascinating, and then this pottery we'll talk about before we get to the whole what you think the pyramid is. So the pottery, like these vases that you're seeing,
but-
I shouldn't say pottery.
No, they're not
I'm
pottery.
wrong. They're actually solid carved,
Right.
and they're carved out of very hard stone, right? What is it? They're carved out of
Oh, granite, diorite. Buffalo,
granite diorite. And
igneous rock. Mm-hmm.
and the crazy thing is how well they're done. And if you show it, could you pick that thing up to show everybody?
Mm-hmm.
The crazy thing is that it's not only perfectly symmetrical. Again, don't use the word perfect, right? Because it's within what width of a human hair?
Well, you got
It's some crazy
yeah, like 2.5 thousandths or something like
2.5 thousandth of a human
that. Have
hair.
you ever used one of these?
Yes, I have.
All right, so measure the lip there, right? See that?
Yes, sir.
Measure that, and then turn it 90 degrees and measure it. And
Okay,
tell
well,
me
this
what you
obviously is not a real one. You wouldn't be letting me hold
get. No,
it.
that is actually a 3D print
Right, 3D print.
from
yeah, not a real
from the
one.
STL file.
Right, but it's not a real one.
No, obviously not.
Okay.
But it's a copy of the
Right.
original.
And so
Basically,
So I'm measuring it here, and then I'm going to measure it here. So it's essentially exactly the same everywhere, right? Is that the idea?
it's within about hour and a half.
It's
Maybe
got a little
two.
bit of a chip in the top
Yeah,
of the lip.
well, you don't. Yeah,
Because that's how it was, right?
don't measure that.
And so it's perfect, except up to what percentage of human hair again?
I would say in shop talk, it's perfect. Yeah.
In
But
shop talk, it's perfect.
Yeah, but it's a human hair, 2.5 thousand, 3,000.
So this is how you measured it all with this equipment.
Well, this was a different.
But the thing is, it's like you couldn't spin this on a potter's wheel. This
No.
is where it gets really crazy.
No.
Because of these handles.
right.
Now these handles are also carved into the vase, and
Right.
people would say, "Well, what's the big deal about a vase?"
Right.
The big deal is these goddamn handles.
That's a big deal.
Because even if you just slowly and meticulously, with the finest of craftsmanship, spun this to a perfect accuracy, just with like high grit sandpaper, where slowly over time made it perfectly round, and you got so good at it that you get it within how much of a human hair again?
About a human hair.
Okay,
Two and a half though.
Okay, let's say it's a human hair, which is pretty small. How the hell are you going to do these handles? How are you going to make these perfect too?
There's another question that you need to ask too.
How do you get the inside out?
No.
What?
How do you measure it to be sure that you're within that human hair?
Right. What kind of equipment are you using?
What kind of instruments do you use?
Yeah, it seems like this would be a problem. Like, I don't think they had this. And if they did have this, they didn't have this part.
How do you know?
I don't know. I'm guessing.
I don't know either.
No. But we're thinking about what they had. We're not thinking about things like this. But
No.
we really don't know.
Well,
Well,
we
obviously we don't know if we can't locate that drill. If you can't locate that drill, like the drill's real, the hole's real. If you can't locate an ancient Egyptian drill, so there's a bunch of pieces of pottery,
Yeah.
and all of them have the same sort of similar measurement to them in terms of their perfection.
Actually, some of them. There's one. I think it's more precise than that one.
Really?
The original, yeah. They call it the spinner. I think it's that one at the front there. And we rotated that on the Rotab at Danville Metal Stamping, and we staged it so that we were checking concentricity or run out all around. So we put an indicator in various places, and then spun the rotary table to check the run out. And that one spinner vase blew me away. You know, when you have when you're measuring a diameter, right, just a straight diameter, and you're checking the run out on a straight diameter, and you have it, okay, that's within 2,000. You only have that one axis that is actually affecting the movement of that indicator that you're using. On this bowl, when you're on the side of it, on the crown, not right to the top, but just below it, you're at a place where the movement in two axes is affecting the indicator reading. So any error that you have vertically or horizontally,
They meet at the top.
yeah, you're gonna get an accumulation of error in runout.
And how
if there
accurate was
is
that
any.
one, the spinner?
There was probably within 1.5 hours.
What does that mean?
1,000. Well, about half the thickness of a human hair.
Half the thickness of a human hair. And one of the vases that's incredibly impressive is there's one with a longer neck and a lip on the top, and then it bowls out of the bottom.
Yeah,
and
right.
It's, again, all carved out of granite somehow.
Right.
And how? What did they do to do that?
Well, that's the thing. I think we're
there's some other ones, Jamie. There's one of them that has like a longer neck. See if you can find it online, maybe.
Yeah, we seem to be stuck in a time warp where we're trying to come to terms with how the pyramids were built, with how all these artifacts were built. Here. Oh, okay. That's a nice posh cup. Can I keep this?
Yes, sir. It's all yours.
Cheers, mate.
Thank you for being here.
All right.
So, continue. So we're lost in history.
So, yeah, I mean, so we have competing forces. We've got, on one side, you have practical engineers, practical scientists, and they want to measure everything exactly, and regardless of what current theories prescribe how they were made, they want to explore other methods. However, on the other side, on the side of not engineers, archaeologists or Egyptologists, they believe that if you're examining an ancient artifact and you're a modern engineer, that you have to work under the guidance of an archaeologist or an Egyptologist. Otherwise, your work would not be recognized.
That's weird.
And that is happening. I mean, that's a fact, and they admit it. So that is the situation. I think it's a systemic problem because it is certainly not a way to do science.
Well, and also they're not educated in those disciplines, supposedly.
Well, bingo, yes. I mean,
so
absolutely.
they wouldn't be able to understand what's required to do that. Now, what the conventional explanation being some sort of copper and sand, if that's the conventional explanation, there's no evidence of any copper drills, correct?
If you go to the Cairo Museum, they have I think there's a tube that they describe, a small tube that they describe as a...
but nothing that can
like that.
Carve those large holes out of granite.
Right. Yeah, they're just going on the assumption that only copper existed during that period, and so that was the metal that was available to them. That was the metal that
the tubes that they have in the museum, are these tubes authentic tubes that were used on the site for something?
I would have to go back and refresh my memory on that because it was quite a while before I looked at it.
But the point is, like, they don't, like they have a replica of an ancient boat. They know they have boats. They know what the boats look like. They don't have the actual drill. So whether it's something exotic that we didn't know that they had capability to create, or whether it's what they think it is, neither one of those exist.
They don't exist.
Okay.
No, I mean, nothing exists. Everything right now is theory.
Okay.
And so we're stuck in a bit of a time walk, and we're stuck. It's between two disciplines.
So what is the reluctance of the archaeologists to accept the findings of the engineers if the goal is the truth? So if the goal is to figure out, instead of just having assumptions that you're going to cling to as dogma as to what was done, wouldn't the goal be, let's find out what the truth is, what's capable of doing this? If they talk to enough engineers, and especially enough people that actually carve into granite,
right,
then you would get an understanding of what we know today. This is the only thing that can do this. This is how it's possible.
Yeah, and then you would try and reproduce the artifacts that the ancient Egyptians produced,
right,
and then compare the results.
Right.
That's what you have to do. You have to...
So the reluctance is they don't believe that the Egyptians had any more advanced technology than what we assume they had, which is pulleys and ropes and copper tools and sand and the like.
Yeah, one would assume that. You'd have to ask an Egyptologist, and you may get a different answer depending on who you ask.
I'm sure.
Yeah.
I'm sure. There's probably a lot more open-minded people coming up now.
Well, yes, particularly in Egypt.
Yeah.
Yeah, there's a tremendous kind of quiet revolution going on in Egypt because you go where you feel like you're going to be welcome. You know, if you're not welcome somewhere, you find someone. So when I put my work out, and I was talking to people in the 90s on message boards, and I could see that, you know, I wasn't getting anywhere there. And I thought, well, okay, who has the most to gain and who has the most to lose by opening this up and exposing everything, right, and getting it out in the open? Who has the most to gain if they come down on my side, and who has the most to lose? And obviously, those who have the most to lose are the Western institutions who have written the history of the world and written the history of Egypt. And so I decided, well, I have to appeal to Egyptian engineers. And so in my second book, Lost Technologies of Ancient Egypt, I put out a challenge to modern Egyptian engineers to go out and check the artifacts for themselves. And that's what they did. One man, one engineer, I don't know how many other engineers were involved, but I'm talking to Egyptology tour guides, and the message I'm getting is that the pyramid of tomb theory is pretty much on the way out. The young people are being energized and looking at their artifacts in a different way. So the engineer that took up the challenge is it's called Ahmed Adli, and he followed my path. He went into the Serapeum and checked those huge granite boxes. He did a study of the statues. He presented the Giza Power Plant theory to a physicist at Cairo University, and it's like, wow, times are changing. So the Egyptian youth are taking hold of the reins, and they're excited about their future. You know, just recently there's like a STEM class. It was put on by Nama American University, and it was held at the Grand Egyptian Museum, and there were over 200 students that took place, and the professors and teachers of these students got Ahmed Adli involved to design experiments to talk about pyramids as energy sources, talk about the statues, symmetry, design projects that the kids could do, and even to the point of taking a slab of copper and trying to cut a brick using the old method, just so that they could get a hands-on feel for what it was like. It's all very well to sit at home in your armchair and come up with a theory, but if you don't go out and test it, then or you're just going to buy it rope. That
Right.
Okay. A respected professor tells me that this was done with copper chisels or copper slabs, and well, if he says it, then he's got to be right, because that's what he's paid for. He's paid to teach the truth.
What is the oldest known iron that we are aware of?
Oh,
in terms of steel.
Yeah, that's a little outside my wheelhouse. I don't know. I won't be able to answer that accurately.
Right, but they don't think that the Egyptians had it.
Well, There was metal, iron found in the Great Pyramid.
There was.
Yeah. I think it was during Petri's time, a engineer called Perring discovered an iron plate that was lodged near one of the shafts.
Wasn't there also, didn't one of the pharaohs have a dagger that was made from a meteorite?
Supposedly, yeah, meteoric iron, yeah.
Okay, so
how old is that? I don't know. And really, when you talk about the smelting of iron, I mean, I think you had that discussion on with your when Graham and
did we talk about that, Jamie? Like when?
And yeah,
I remember smelting being. It could have been though, but I don't.
Let's find out what is the conventional date that they use today for the smelting of iron. When they start doing that?
I think what the discussion was the appearance of lead in these ice cores that were drilled.
Oh, that's right. Right.
Industrial activity,
Yes.
basically,
Yeah.
what they were looking for.
So 1200 BC. Okay, the history of Ferrous. How do you say that word? Ferrous metallurgy began far back in prehistory, most likely with the use of iron from meteors. There you go. The smelting of iron bloomeries. Is that it? Bloomeries? Is that what you say?
Yeah.
Began in the 12th century BC in India, Anatolia, or the Caucasus. Iron used in smelting and forging for tools appeared in sub-Saharan Africa by 1200 BC. So it could be that these pharaohs, that the one that had the iron dagger made out of a meteorite, maybe that was later.
Yeah, absolutely.
Yeah, Tutankhamun. Okay, so for sure it was. Look at that. Meteoric iron dagger. Wow.
Yeah.
So that's 1334 to 1325 BC. Interesting.
Mm-hmm.
Well, that's earlier. That's earlier than they said people were smelting.
Yeah, but they found it. They don't know when they made it.
Yeah,
Right.
but
Who knows where
that's
it came
different.
from.
Right, but if it's Tutankhamun, that's his time.
Yeah.
Yeah, but that iron came from outer space. So.
Right, but so they could have hammered it into that position.
Yeah,
So they didn't have
yeah,
to smelt it.
Pretty
Right.
much.
So we know they're aware of it at least at 1300 BC. We know
Yeah.
they're aware of iron, but
Well-
there's just no evidence of tools.
Yeah, I mean, I can't. I wouldn't say. I don't know if they knew what the metallurgy of these materials that
Right.
they found, but yeah, they had a material that they could shape, and they shaped it into a dagger.
But we don't know if they shaped it into tools or shaped it into some
This
other
piece
things.
says that the iron plate right here says it was unlikely that it was the byproduct of copper smelting operations. It was badly corroded.
The outer layer of the iron have been badly corroded and now form
Yeah, that's
expanded
right.
iron oxide. Significant proportions of gold were found in one of the oxidized layers, and the plate may originally have been gold-plated. New data coupled with the original archaeological information strongly suggests the iron plate is contemporary with the building of the pyramid and that it is, therefore, one of the oldest known pieces of iron.
Yeah, I think Petri described it as having nummulites that had somehow been deposited on the surface.
So at least that's
That's
some
right.
evidence of iron in the
Right.
Great Pyramid.
But, as far as what iron was it smelted?
Right. And
that's the question.
did they have the
and-
capability of doing that?
And when?
Right, and when?
Right.
Right. So it's just pure speculation as to what they used for the core. What is the conventional thought as to how they made these vases?
I mean, there are demonstrations of crafting ancient vases, but I think this recent research and the discovery of the precision of them, which had always been a question mark until just recently. People would go through the Cairo Museum or in any museum in the world, and they'd see these beautiful, finely crafted artifacts made out of igneous rock, and they look extraordinarily precise. And I've done that the same. I mean, I look at them and it's like, wow, I'd like to get one of those in my shop and just check it out, quality inspection. And so for years, that was for me, it was like always a question. love to know how precise those vases are. And then in 2018, the owner of that original vase, Adam Young, he came on the tour, and he befriended my son Alex, and they were talking about the vases, and Alex was a quality inspector, quality engineer to the company that I worked at. Since he worked at another company in Indianapolis, and now I think he's working in the metrology lab at Rolls-Royce in Indianapolis. And so he's like, well, we should scan them or do an inspection of them. So Adam brought his vase down to Indianapolis and to where Alex was working, and he got permission from the managers at the shop to do an inspection of them. And it seems like, you talk to people, shop people, right? People who are actually out there every day making quality parts that people's lives depend on. If you fly on an airplane and you... And I told one of there's another owner of vases, he's got a lot of them. And I told him, I said, you're carrying in your hand an artifact that is more precise than some of the parts that were installed in the engine that was on the plane that you flew in.
That's
and
crazy.
He's like, wow, okay. I mean, that's where you bring it home. And so all these guys who are making these artifacts, right, and they're held to exacting standards every day. They can't slip up. They can't make mistakes. There's no fudging or faking anything. Otherwise, you'd be out on your ear, or people would be falling out of the skies. Well,
Right.
Yeah, right.
So that's for those parts, and these artifacts were more precise than that, which is just insane.
Well, not all of them. I mean, there are parts in an airplane engine or aircraft engine that are more precise. I mean, or features of the parts are more precise, and that's where. And I want to explain something here because
Sure.
I think it's a very, very important point, and it has confused a lot of people. It really confused a lot of people. The any part that you have, whether it's something for your car, say a crankshaft or something like that, right? You take a crankshaft, it's got very precise features on it, and then there are features that are not so precise because they don't need to be. It all depends on what the customer requirements are. So they don't build precision or require precision in a product where it's not needed. That just
Right.
wastes of time.
Right.
It just makes it more expensive. But now you have people who are looking at some of these artifacts, like the boxes in the Serapeum, and they're finding imprecise areas of the boxes. The photograph of me inside one of those boxes with a toolmaker's precision square. I mean, there's nothing simpler, right? You take a
Right.
square, you stick it out, and you check to see if it's square. Are the surfaces flat? Is it square? Yeah, that's fine. And now you've got guys going around on the outside of the box and finding inaccuracies. Some areas inside boxes that have inaccuracies. And now they're calling me a liar. They say that I faked and fudged measurements. Right? It's like, I don't know, the cancel culture they want to
So
get away from.
what is their beef? Like, you used a square,
Yeah.
and you measured things, and you found
Yeah.
them to be precise.
And I said, holy shit, look at this.
And what are they using?
Before
What
me?
equipment are they using that's showing that your equipment, what your measurements were inaccurate?
They are not. They don't go to the area and show that the area that I was checking is imprecise. they will find some other area that is less precise, point to that, and lead the viewer to believe that defines everything.
Right. So everything is not precise, but much of it is.
Yes.
Okay.
Yeah.
And the areas that aren't necessary to be precise, like the outside of the box, are not as precise as the inside? Is that what you're saying?
They don't have to be.
Right. They don't have to be.
Right.
So when it comes to precision, like the precision of the faces, for instance,
Yeah.
and some of the sculptures,
Right.
what is the conventional explanation for how precise they are? Because these are massive faces that were supposedly carved by hand, but the accuracy on either side of the face is so phenomenal,
Yeah.
like bizarrely so. Like how accurate?
Well, exactly, we don't know. But I mean, as far as the methods that I used, which is like 2D photography, and then comparing features in the computer for symmetry, and some geometric features. Nobody had done that before, and so I come along, I said, wow, this is actually it kind of hit me. It was the first time I went to Egypt, and I was at Saqqara, and I was looking down the length of the statue of Ramses at the open air museum there. And I said, well, the nostrils are extraordinarily symmetrical. I mean, they match, right? And most people's nostrils are different if you look at them. And so that's my photograph.
There's the measurements
Right.
on each side. They're exact.
Yeah, they're as exact as I could make it. But, I qualify the work that I did by saying this is not the final answer. There needs to be more sophisticated measurements taken, more accurate measurements taken. They need to be scanned, and then they need to be analyzed where you have a precise scan where you're not trusting your eyes. You're actually trusting, the tried and true development of laser scanners.
But at the very least, the amount of symmetry that exists in these massive statues is spectacular.
It's mind blowing. I can't even express it. It's absolutely mind blowing. You look at the one with the.
How large are these that we're talking about?
Well, the one that I measured was the first one was at the Luxor Museum, and it's outside. I would say it's probably 4 feet or something.
But there's very large ones too, right?
Just the face, like the face and the headdress. There are larger ones, yes. I think the one that was taken from the Ramesseum and is now in the British Museum was a large statue.
How big was that?
I think. Well, they say that the statues at the Ramesseum weigh up to 1,000 tons. I'm not sure, but they're really big, really big.
1,000 tons. Look at that.
Well,
face.
I wouldn't want to say 1,000 tons, but I would say they were extremely heavy.
Now, what is the conventional speculation as to how this symmetry was achieved?
I've heard different ideas where you take a mirror and then you kind of match it to, when it guides your hand, and another one where you take a pointer and you set a depth and then you transfer that from one side to the other. And those are, I don't know anybody who is a precision manufacturer who would accept such an explanation. And really, at the end of the day, you have to say, okay, well, show me, and we'll match. If show me, and we'll check yours and compare it to the original. That's the only way to solve the problem.
And so this is just one example of one of the mind-blowing mysteries involved in this culture, that they had some kind of capability of not just doing that and not just making the vases, but also making the pyramids themselves, which are beyond comprehension.
It's huge. I mean, the thing is that you have, I wouldn't say, not all engineers think alike, right? But I've never been with an engineer who has examined this subject and been to Egypt that is not absolutely blown away by what they're seeing, and are saying, no, you can't do it by hand. You can't hold those kind of tolerances by hand. You look at the Ramses statue and you look at the symmetry. It's not two-dimensional symmetry. I mean, I was just measuring a two-dimensional photograph. It's not two-dimensional, it's three-dimensional. So that radius that you see going around the jawline is moving in 3 axes, right? X, Y, Z. Mm-hmm. And you're still coming up with a radius, perfect radius.
Crazy.
Nuts.
Yeah. So let's go to the pyramid itself. So you have a very fascinating hypothesis as to what the pyramid, or theory, as to what the pyramid actually was. Mm-hmm. And it's based on where the supposed king's chamber is, where those passages go through into it. And what do you think that thing was?
Well, my first book pretty much describes what I thought it was in 1998, which was a power plant. The book is entitled The Giza Power Plant. My second book has evolved, and I describe it as an electron harvester. So, it's kind of like, you could describe it as both, but and today, when you do, or, people, in any decade, they think of a power plant and they see these huge chimneys with smokestacks
or a nuke plant.
Yeah, or a nuke plant. A power plant, dirty, nasty, unclean. Mm-hmm. But an electron harvester, clean, pollution-free, not a problem.
Has that been achieved conventionally? I mean, today, is there a thing called an electron harvester?
I think that actually, when you look at a generator, that's an electron harvester, because we don't create electrons; we just harvest them. It's just how we do it, and so when you say an electron harvester, you could say that say a wind you have a windmill, and you have a generator inside it, and then you're collecting electrons off the commutator in a generator.
And that's where the electricity comes from.
And that's your electricity.
Right. Or hydroelectric, you'd use the flow of the water.
Yeah, you don't create you just release them.
You harvest it from a process.
You harvest them through a process.
And the process that you think they used in the Great Pyramid involved those shafts?
It involves a lot of things. Yeah, it's not just one single thing. It's a system. Not a single thing. So when you look,
can we show a photo of that? Do we have a photo of the pyramids and the shafts and where the king's chamber is? I know you've described this before. Mm-hmm. Do you have a photo of?
I do. It's in the.
I was trying to figure out which one you wanted.
Okay, this is perfect. This works.
Yeah, that works.
So these names, the king's chamber and the queen's chamber, you don't think that that's actually a king's chamber or a queen's chamber? You think it's something else?
Well, out of respect to the Egyptians, I
call it what they say it is.
Yeah.
Okay.
But I do have a different terminology for them as they function.
Now, the initial surface of the Great Pyramid is covered in smooth limestone, right? So it's polished and shiny, and apparently it would collect insane amounts of light.
The outer surface of the Great Pyramid mostly is missing, and,
right?
But it has been described as if it was finished and depending on the polish that it received, yeah, it could reflect a lot of light.
Do you think that had something to do with the design of this power plant?
I don't think there's any part of that pyramid that did not serve a practical function.
Okay, so this is the image that you have here, and what
Right.
this image shows us is the King's Chamber, the various shafts, the southern shaft, the northern shaft, and these shafts have been described as portals to stars because people have looked up through there, and you go through the shaft, you see stars. But what you're saying is something entirely different. What do you think these shafts were for?
Well, I think they serve two different purposes. Actually, four different purposes, if you will, because in the theory that I propose, which is, I don't know, it's a speculation, a theory. The whole process is kind of like a heuristic process where you're grabbing information, you're moving it. Doesn't matter what source you're getting it from.
Right.
Because when you are looking for answers, you look everywhere. You try and find, you look everywhere. So when I was going through the process of trying to figure it out, I was collecting information from everywhere. And one of for the southern shaft and the northern shaft of the Queen's Chamber, that was a huge mystery to me, and I tried to fit it into what were they doing? I mean, if you look at the details, the facts of their design and what the ancient Egyptians were doing, why they designed them that way, you have two conduits coming into a chamber, but they're not connected to the chamber. And we didn't even know they existed until 1872 or for Wayman Dixon.
Can you show me that image again, please? So they're coming into the chamber, but they don't enter into the chamber. So they stop.
Their original design had them the shafts ending 5 inches before coming into the chamber. So you had like 5 inches of limestone that was left in the block.
So did someone remove that limestone?
Yes.
Why did they do that?
Wayman Dixon, because they were examining the chamber and they were poking around. And Wayman Dixon, it is reported, so the legend goes, noticed a crack in the wall. And so he took a rod and pushed it through the crack. And the rod, it didn't meet any resistance. It kept going. So he had his worker come in, Bill Grundy, with a hammer and chisel, and say, chisel the limestone around that.
God, people are stupid. So,
well, they did. Yeah, they didn't have ultrasonic thickness test.
No, but still, God damn, to have the arrogance to go and chip away at the pyramid because
well,
you're
you
curious.
Look at how advanced. I don't care for revisionist historians because you have to consider what people were doing, their mindset in the day, and then I try to look at on the bright side. Right? It's like I don't look at it as a negative thing because if somebody hadn't opened up those shafts, we wouldn't know about them.
Right.
And it's the same with the chambers above the King's Chamber. Without Howard Vyse and his military expedition blasting his way up into the pyramid, we wouldn't know about them either. You won't be. I mean, there's a lot there. I think there's a lot there right now, and it's being investigated now. But there's things that have been revealed through scanning, like muography, the Scan Pyramid Project, and they found that large void above the Grand Gallery.
Right.
And so,
which is larger than the King's Chamber, right?
It's longer than the King's Chamber, yeah.
And so is that's not even represented here on this?
It's about the size of the cabin on a Boeing 707.
Wow. So if these shafts came through and then they met limestone at the end, what do you think was going on?
In order to answer that question, I had to look at the rest of the pyramid. Okay, what was it doing, and how was it functioning? And so one of the key pieces of evidence that I used to propose a process that was going on is the northern shaft. And the northern shaft has dimensions and has an appearance that is similar to a waveguide that you would use for microwaves. And the dimensions of it would approximate the wavelength of hydrogen.
So, explain a waveguide. How does that work?
Yeah, it's like a waveguide is to transmit microwaves, electromagnetic energy, in the microwave region, and it is passed more efficiently through like a tube or waveguide, and that's what they use. I mean, they're very complicated systems,
And so, how did this represent, in your mind, what a waveguide looks like?
Actually, the idea of a waveguide came to me from a guy. We were talking about the pyramids, and I used to carry a schematic of the Great Pyramid in my back pocket, and I meet an engineer, and I go, hey, come here. Start going through. So what do you think about this? Because, I was looking for answers, suggestions, brainstorming, anything, right? And it's like, so anyway, these shafts right here, and he looks at it, and he was into electronic engineering, and he's like, they look like waveguides to me. And I thought, well, that's interesting. They look like waveguides. Okay. What if they are waveguides? How did they function? I mean, what were they used for? What were they using waveguides for in ancient Egypt? And so I started to go down that rabbit hole, and that led me to the Queen's Chamber. I say, okay, waveguides. You need a medium. You need microwaves to go through a waveguide. What frequency of microwave was it, right? And you look at the dimensions, and you come up with a match for hydrogen. Oh,
how do you do that? How do you come up with a match for hydrogen through the dimensions?
Yeah. The wavelength of hydrogen is 8.309 inches, and the width of the northern shaft is 8.4 inches. And a waveguide generally has the wavelength and then about half of the wavelength in height. So it's a rectangular shaft.
Just like all the shafts are.
Right.
Yeah.
And the Queen's Chamber shaft is a little more square than the King's Chamber shaft.
So it had a different function?
Different function, yeah.
So these waveguides, you believe, what are they collecting, and where are they getting it from?
Good question, Joe. They had we are bombarded with microwaves every day. I mean, it's the signal from, they say, the Big Bang, and there's it comes from atomic hydrogen out in the universe, in outer space. But
so we're being bombarded, and you believe that these passages were collecting this.
Yeah. So anyway, so then you say, okay, if we build a device and we say, and we want to energize hydrogen, we bring it to a higher energy state, and just like in a laser, where you have microwave amplification through stimulated emission, right? So if we want to collect energy that is in a gaseous medium, say that is hydrogen medium, and the electrons in the hydrogen are pumped up to a higher energy state, and we want to collect the energy in that, introduce a microwave signal, direct it through that gas and stimulate the emission of the energy, collect that energy, and shoot it up the southern shaft. And so that was like, okay, that might work.
So what kind of gas?
Hydrogen.
And so where are you getting the hydrogen from?
Queen's chamber.
So there's hydrogen in the Queen's chamber, and how does it get in there?
The shafts. But it doesn't come in as hydrogen. That's a part of the theory in the Giza Power Plant was there are two chemicals that are introduced into the chamber, and the chemicals mix and they boil off hydrogen.
And these chemicals are just coming from the radioactive waves of space?
No. The chemicals, I believe, are manufactured and delivered to those shafts and coming.
Okay.
Right.
So they add some sort of chemicals
Right.
to it.
Right.
And what function does the limestone have at the end that keeps it from going into the King's chamber, that keeps it blocked off?
Well, to answer that question, I was having a chat with a civil engineer who was putting in a septic system for me, and so with a leach field, and he was doing a percolation test, right? This is in Indiana, and Indiana is known for its fine limestone. His name was Roland Dove, a city engineer, and I asked him, I said, well, what do you do? How does this function if you are in an area where there's not much topsoil? You scrape away maybe a foot of topsoil, and then you're on the bedrock. What do you do then? And he said, well, if limestone is permeable, and basically you follow the same steps that you would as if you were digging into earth, just dirt. You dig a hole, you cut a hole in the limestone, and you determine how quickly the water would disperse or would actually seep out. And I was like, wow, okay.
So the limestone acts as a filter.
Not a well, I mean, it would a filter, yes, but definitely the water would not just stay there.
Right, it would go through it.
It would go through it.
Mm-hmm.
But it would go through it at a certain rate. And I said, okay. I said, let me ask you this. How do you determine the flow rate? How would you determine the flow rate of a column of water, right, going through limestone? And he said, well, that would depend on the head pressure, how much pressure, what weight is pushing against the limestone.
Right.
Right? And I go, okay, that's interesting. So then I go back to the drawing boards. I go back to my blueprints of the Great Pyramid, and I'm looking at the southern northern shaft of the Queen's Chamber, and I see that both of these shafts go up to an area that nobody knows where it goes. At that time, when I was doing research, nobody knew where they ended. But I was thinking, well, if they are feeding a chemical, they would need to be assured that they can maintain a particular head pressure. That would be calculated, the weight of the column of fluid. And essentially, as these are on an angle, your calculations may get a little more complicated, but you would figure it out, or you could do it by trial and error. But not all the evidence was in to really kind of solidify that theory, right? It's like, okay, I've got this much data. This is what I'm working with. There's a lot of unknowns. I don't know. So what do we do? And then in 1993, a German engineer, Rudolf Gantenbrink, he was invited to Egypt, and he was working under the German mission in Cairo, and he had permission to, or they wanted him to actually get a robot, examine all those shafts, both the King's Chamber and the Queen's Chamber. Actually, no, mostly the King's Chamber. They wanted to ventilate the pyramids, and so they wanted to make sure that the shafts were clear, and that when they install their fans, that there won't be any obstruction. And so he built a robot to go through these, clean the shafts out, and then install fans in the King's Chamber. But it had always been a mystery in the as far as the Queen's Chamber shafts. Where did they end? Nobody knew. Nobody had explored them that far. So he proposed that they allow him to build another robot and examine the shafts in the Queen's Chamber, which he did that. He had a robot, they called it Upwat 2, which means the opening of the ways.
Oh.
Right. And so with his robot, he had he had a tether behind it, and a camera, lights, and it crawled its way. It was like a track vehicle, and there was a mechanism for the upper track that caused it to grip the ceiling, and it was able to climb up the shaft. And they were looking for where it ended. And they found where it ended after a few kind of obstacles. One being what he called a tank trap, which was like a depression in the floor of the shaft, of about a drop of about 2 inches, which is another story entirely. I don't think the full truth of why that is there has been figured out yet or explained, but they're working on it. And so his robot got so far up the shaft, and they discovered that there was a block at the end of the shaft, and through the block are 2 metal fittings.
Metal. What kind of metal?
I don't know.
So a person hasn't gone over there and gotten a sample of it, so they don't really know. It's just speculation.
I don't know.
There's some kind of metal fittings.
They assumed that they were copper.
And how far is it from the outside edge of the pyramid?
Well, you do ask some awkward questions. I don't have that information in front of me. But I would say that if you are wanting to reach the end of where that southern shaft is, the shortest route that you could take would be through a horizontal passage that goes directly out to the outer surface of the Great Pyramid. Just a horizontal passage.
Okay.
Going up, going down.
Can I see the image again, please? So what we're looking at when you're seeing the shafts. Hold on a second. No worries.
More helpful with that part, or do you want the whole thing?
I want to see what it looks like on the outside. Yeah, that one.
Yeah.
So say it again. What would be the best way to access it?
Yeah, I mean, if you go to the end of the shaft and just have a short horizontal shaft or passage going out to the outer face, you would have a shorter distance than if you went up, or down. So that would be the ideal place to have access to it.
But it doesn't go. This makes it look like it goes all the way to the outside edge of the pyramid. That's not the case?
What, the Queen's Chamber shaft?
No, the King's Chamber shaft.
Well, the King's Chamber shaft does go to the outside.
It goes all the way outside.
It goes all the way
through.
to the outside, yeah.
Okay.
Yeah.
And so the Queen's Chamber shaft, it stops quite a bit before the outside edge of the pyramid.
Right.
So both of them function in a different way.
Yes.
And so you feel like in the King's Chamber shaft that something was poured in, some kind of chemicals was poured into
In
those
Queen's
shafts.
Chamber shaft. Yeah.
Queen's Chamber shaft.
Yeah.
But not the King's Chamber
Not
shaft.
not the King's Chamber
Okay.
shaft.
So the Queen's Chamber shaft, what is the difference and why do you think that there was chemicals poured in that and not into the King's Chamber?
Because the Queen's Chamber was a reaction chamber, so that's where the hydrogen was produced. The hydrogen filled the interior spaces of the Great Pyramid, and also which included the King's Chamber. And then through the different actions, whether it be the Freund effect, which we can talk about, and that's the release of electrons from the lithosphere, or the accumulation of vibration, or the collection of vibration, and how it was centered or focused into the King's Chamber, it created a highly energized atmosphere.
So
It was.
Have they found access to the northern and southern shafts in the Queen's Chamber?
To the
shafts. Have they found access where the Egyptians would have been able to pour chemicals into those?
No, not yet.
Not yet.
No.
But they have found something that's not represented on this image, another chamber, right, which is more recent.
Right. I mean, the my new book has updated images in it to describe what new has been discovered.
And that new chamber is above the King's Chamber, is that correct?
It's actually above the Grand Gallery.
Okay.
And it kind of wraps around, or is, close to the northern shaft. That's an interesting place for it to be too, which prompted my research associate Eric Wilson, who's a aerospace engineer, to suggest that actually feature, if it is what he thinks it is, would complete my theory, because it would serve as a preamp for the microwave. So the microwave, he said that was the thing that was missing in my theory, was that there was no preamp.
So is there an image that we can look at that shows where this new chamber, the newly discovered, I should say, chamber?
Could I take a break?
Yeah, sure.
I need to go to...
Yeah, absolutely. Yeah. We'll be right back.
All right.
So you were just discussing the chambers and how you believe fluid was in the shafts of the Queen's Chamber, and that it somehow or another created hydrogen with these chemicals. How is the microwave going through those chambers if it's blocked off from the outside? Is it penetrating through the stone?
Well, it doesn't go into the Queen's Chamber, so it's through the King's Chamber shafts, which are open.
Okay, so the King's Chamber shafts is what's collecting the microwaves. The Queen's Chamber shafts have what you believe some chemicals in there.
Right.
And then what is happening with those chemicals?
They're mixing and boiling off hydrogen.
Okay, so they're creating hydrogen.
Right.
And what is the function of the space in those shafts? Is that help the chemical process? Is that what it is?
The space in the shafts.
Where they're filling them up with liquid?
Oh, yes. That is predetermined to make sure that they maintain the head pressure. The fittings, or the metal fittings, I describe as switches, like fluid switches.
Mm-hmm.
So when the fluid or the chemical was covering those metal fittings, I call them electrodes. There would be a closed circuit when the fluid level dropped. It would open the circuit and signal the need for more chemicals to be pumped in order to maintain the head pressure, in order to make sure that there is an accurate supply of that chemical.
And so that chemical would pool up inside of the Queen's Chamber?
It would probably, yes. I mean, there's a lot that is missing from the Queen's Chamber. You have a niche in the east wall. We don't know what that was for. I suspect that it had something to do with, there may have been an evaporation tower or something like that, where the chemicals mixed and wicked up through some materials, and maybe it dried.
Can you show me the image again, please?
Yeah.
And so here we have, so there's the chemicals that are in the shafts. You have the Queen's chamber, which is collecting the hydrogen, and then what happens into the King's chamber?
Well, while that is going on, the King's chamber is vibrating in sympathy with the Earth, and it is actually a coupled oscillator with the Earth.
How so? How does that work?
Well, a coupled oscillator is a device that's attached to a larger vibrating device and is in sympathy.
And
with
what is causing the King's chamber to vibrate?
The passage of vibration through the pyramid.
Of the Earth.
Of the Earth, which is assisted. It's coupled by using what I call a Tesla device in the subterranean chamber, because you've got several systems in there, right? So if you got the subterranean chamber, that serves one function. You go up to the Queen's chamber, that serves another function. You go up to the King's chamber, that serves another function. And in between, you have the Grand Gallery, the ascending passage, got the descending passage. All of these things are there for a reason.
And so the subterranean chamber, how do you think that worked?
I would speculate that, and actually, if you read Tesla and some of his writings, he suggests that with a very little energy, you could build a device that imparts energy or thrusts into a structure, and if it is in harmony or the exact frequency with that structure, it could bring the structure down just by an accumulation of energy, of vibration. The amplitude would keep, and if you kept pounding it and pounding it and pounding it, eventually it would all come down. That's why they instructed soldiers when they're on the march to break step when they cross a bridge, because their footsteps might cause the bridge to oscillate and destroy. It's a very destructive force. This frequency or
Oscillating vibration.
oscillating vibrations. Yeah.
So what kind of device in the subterranean chamber would do that?
He built a device that delivered thrusts and powers. It was electromagnetic earthquake machine, it's called, right? Mm-hmm. You could do it electromechanical, you could do electrohydraulic, or just anything. But you have to be able to time the action. And so, you think of it like you've got a device, you've got a cylinder, you got a shaft coming out of it, and you got a hammer, or you got a copper pad or whatever at the end of it, and you design it so that shaft is going to push out at a particular frequency. So you go
like a piston.
Boom, 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 and so you put it against a structure. That structure has a natural frequency. Right? All structures do. You might hit one with a fist and don't think it would resonate at all. But if you go, the first strike may impart enough energy to move something, maybe a couple of angstroms, right? Mm-hmm. And so it's like very, very minute movement.
Right.
The next one will move it a little more. Then you just keep pounding it. And as you pound it, the oscillations become bigger, the amplitude becomes bigger, and if you keep doing it, you can bring the whole thing down.
So the key is to do it at a rate that is able to utilize the hydrogen.
Well, at this point, hydrogen has nothing to do with it. I mean,
Okay.
this is just a totally separate subsystem. It doesn't care if there's hydrogen in the pyramid.
But this
or
subsystem exists to vibrate the King's
just
pyramid.
just to connect the pyramid
Excuse me.
with the Earth.
Right.
Yes.
Okay. So it's vibrating the pyramid,
Yeah.
and the hydrogen in the Queen's chamber now, it makes its way into the King's chamber.
Well, yes. I mean, it flows up through along the horizontal passage, through the Grand Gallery and up into the King's Chamber.
So all this is connected.
Oh, that's connected.
So the hydrogen goes up, it goes in the King's chamber, which is a phenomenal structure,
Right.
carved out of granite from 500 miles away, massive stones, the biggest stones in the pyramid, correct?
Right.
And so what happens with the vibration of the pyramid through this thing that's connected to the earth in the subterranean chamber, constantly hitting, boom, 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 vibrating.
Right.
The hydrogen flows into the great chamber, the King's chamber, rather, King's chamber is vibrating, and then you have these shafts that come from the outside of the King's chamber into it. So
Right.
what's happening there?
Okay. Well, let's go back to the
Subterranean.
All right.
Okay.
And let's talk about not what happens in the pyramid, but what is happening in the Earth.
Okay.
All right. And this is where we introduced Tesla technology, and also the work of a NASA physicist called Friedemann Freund.
Just keep that thing up there, Jimmy.
So Friedemann Freund has did research on earthquake lines, and his objective was to try to determine if we could detect or if we could have an early warning system for earthquakes. And he was using NASA satellites to survey the Earth and to observe for when earthquake lights show up. And his theory, it's not really a theory, it's a scientific fact, is that in the minerals in igneous rock, you have these positive charge carriers that when they are stressed, they will shoot to the surface. And the positive charge carriers are like, they call them holes. He describes it as a new physics, but it's kind of related to semiconductor physics, which is a little above my head. But but still, he's talking about releasing electrons from deep within the Earth, and those electrons, when they're stimulated to move, they move very, very quickly through the pyramid. Through the Earth, and they seek the highest point on the surface of the Earth. So you have Tesla on one side, and he's saying that if you could put like an earthquake machine and just drive, a frequency into the planet, you might be able to release the stresses in the Earth's crust, and also reduce the possibility of an earthquake. I'm not saying eliminate it entirely, but at least
You would release some pressure.
yeah, you would relieve some
Okay.
pressure. And so, with that, it's it becomes you put in these little bits of disparate information together, and you combine them, and you say, oh, maybe there is something here. I think the biggest discovery, which is not talked about very much, is Friedemann Freund's discovery of of how the physics behind earthquake lights, and he actually experimented in his lab You want to? He has a YouTube. There's a YouTube video with him. He explains it a lot better. Do you want to pull that up and watch it?
We could, but the problem is we'll get flagged.
Oh, okay then.
He uses YouTube video.
Oh, okay. All right. So for those who are listening, you can search Freedom and Freund, and or just Freund, Freund, and TEDx talk in Christchurch, New Zealand. It's an excellent video.
Okay,
but he explains it.
So something is happening in this subterranean chamber.
Yep.
And this something is causing the pyramid and the earth around it to vibrate.
Mm-hmm.
And how is that affecting the hydrogen? And how is that affecting what's happening in the King's Chamber?
Okay, so you have a combination of, you've got two different kinds of energy now flowing through the Great Pyramid. You've got electromagnetic energy, and
from
you've
the
also
ground.
got mechanical energy.
Right.
Right.
Okay, so you've got the mechanical energy of this thing that's striking.
Right.
You have the passages that are filled with chemicals that's causing the accumulation of hydrogen. The hydrogen is making its way into the King's Chamber.
Right.
And then what is the function of these passageways that go into the King's Chamber from the outside?
Well, the northern shaft carries a microwave signal. That signal passes through a amplifier, and then the signal enters into the chamber and collects the energy that has been accumulating in that space. And it's like a laser or maser,
So the chambers are collecting microwave energy from space.
Yeah.
It's going through them, and it's going, the passageways rather. It's going into the chamber, which is vibrating, and it's filled with hydrogen. So what is this reaction that happens when these two things meet?
Okay, the action of that is the same as a laser, where you have the introduction of a photon in a laser, right? That photon passes through an energized medium where the electrons are pumped to a higher energy state. Then that photon collects another photon, and then another one, and it just builds and builds and builds and builds. But it does it at the speed of light, obviously. And so that's why when you say you have a laser pointer, that process is what happens before the light appears on your slide or whatever. You press the button and it's kind of instant, right? But there's been a lot going on since when you press that button to create that laser light.
I see, but it just happens
so fast.
Right.
Yeah.
So this King's Chamber, when it has the hydrogen in it, you have the electrons, you have the vibration of the thing, you have the microwaves coming in. What do you think this?
So you have microwaves coming in, but then you have power output.
Power output.
Yeah. So the power output is the southern shaft, and this is where there's another piece of key evidence. Jamie, could you show the slide that shows the opening of the southern shaft, please?
It's crazy that this makes sense.
Well,
That's what I was trying to get. There's a bunch of slides in here that are really interesting, but we haven't got to them yet.
Well, we got time. We'll get to those.
said Joe. I don't know about me.
You're doing great.
I may pass out.
Have another cup of coffee.
Here's the northern shaft, but I don't know.
Oh, that's the northern shaft. Okay.
Shaft.
Wait a minute. Go to the newer slides. I think there are better images on those. Yeah, these were created back in the day. Okay, hold on. Go.
Yeah, nothing said southern, no.
See, okay, here. Just up here, okay?
Okay.
All right. So my first book, I didn't have a really accurate description of the northern shaft. Okay. And so since then, we got the CAD drawings of Rudolf Gantenbrink when he did an examination. And he did a great job measuring everything, every angle, distance, all the way to the outside. And so this is taken from his CAD drawing, and I just kind of, made it a little more striking and clear, or people could understand the complexity of that shaft. And also to point out some of the details that are pretty mind-blowing. You have 4 bends, 1, 2, 3, 4, before it goes into the king's chamber. Okay? Now, where is that opening? It is at the quarter wave location. And in a resonant cavity, the highest amplitude could be found at a quarter wave. So it's like if you've got a standing wave in a resonant cavity, it's the quarter wave. It's the quarter of the distance along the length of the cavity. That's where your amplitude, that's where your energy is the highest.
So at least in this placement, it affirms your theory. That's where it would be.
Right.
Okay.
But the other thing is, and this information, of course, is common. I mean, I've talked to people who worked on waveguides. Eric Wilson is very familiar with them. And he did a study of Gantenbrink's drawings, and he said, this, and he's pointing out different unusual features in the shaft that seem to appear in the design of modern waveguides, because you have changes in dimension, you have these steps, there is like a bump in an area, and it's all to kind of massage, manipulate the beam as it comes into the pyramid. But then when it comes to entering into the king's chamber, it goes through 4 bends. He said that's to be able to correct the beam, so that when it does enter the pyramid, it is coherent and it goes in straight.
Wow. So it's literally how you would design it.
The other thing, the other thing is that and this is mind-blowing, and it will tell you a lot. There is another drawing of a plan view of of that shaft, Jamie. Hold on, I think. Wait a minute. Yeah, no, below the one with below that one, directly. Yeah, nope, you passed it. Yeah, that one. Okay, so the commonly held theory about why those shafts exist is to ventilate the Great Pyramid, right?
Mm-hmm.
Okay, and that the reason why they have those bends is for it to encircle the Grand Gallery, so that it doesn't interfere, or with the Grand Gallery. Now, if you're just going to ventilate that place, would you need that many bends? But look at the distance between the Grand Gallery wall and the north shaft. It is 13.6 feet, right? If you take where the level where the shaft enters the king's chamber, and you take it straight past the Grand Gallery, you're looking at dimension E, which is 41 inches. So it would clear the Grand Gallery. It didn't have to go through all those bends, unless the wall blocks of the Grand Gallery were so large that they didn't want to interfere with them. And so does that suggest that the wall block thickness, because we don't know how thick they are, but that suggests that they are maybe just a little less than 13 feet thick. That is mind-blowing.
How heavy are those things?
Yeah.
So the way it's set up here now, especially when you're looking at it from this, it really does kind of make sense that this is a passageway for gases and energy. Like the way I'm looking, I mean, it looks like, if you're looking at it like this, it looks like a system.
It's a machine.
You were talking about the southern shaft.
Right.
And that the southern shaft, there's an outside image. We can see it from the outside.
Yeah, could you show that one?
Which image is it?
Oh, it's coming, I think. Well, I think you're going the wrong way, Jamie.
There wasn't another picture the other way. I can Google it if you want me to find it, but I don't know if it was here.
Well, it's in there.
Oh, okay.
Go down.
How many images are in here?
This one goes like 50 feet.
Hundreds. How many did you want?
That's where it stops is right here.
Oh, hold on.
Unless it's in
Look
a
at
different
Oh, wait a minute. No,
folder or
just
something.
above. Right, it was right below the previous picture that we were talking about. Number 47 there. Just below that. Yeah, there. Okay. Okay, so the bottom left photograph is the opening of the southern shaft. The southern shaft of the King's Chamber.
Okay.
I took a photograph of it in 1986, okay? The one on the right, I took in 1995, and that was after Rudolf Gantenbrink had installed the fan. But if you look at that opening, you see that you have like a bulbous opening, almost looks like a microwave horn antenna, right? So it's not just a straight, simple shaft. It's like a catcher's mitt,
Okay. Yeah.
right? I mean, it's just all of these different features of this chamber that you would overlook them, right?
But you would design it that way if you were trying to catch microwaves.
Yeah.
And so the southern shaft and the northern shaft have different functions.
Mm-hmm.
And you believe that the northern shaft is collecting the microwave energy,
It is channeling the microwave.
the microwave
Yeah,
energy.
I mean, they would have some system on the outside to collect them. They may have a very large area actually collecting microwaves and feeding it to a reflector that is directed down the northern shaft. If you know that there are 8 sides to the pyramid, right? Each side it dips in, so it's not. It doesn't go straight across. It dips in. I don't know where that reflector would have been positioned, but they could have been reflecting microwaves off the surface of the Great Pyramid to a reflector at a distance away, and that reflector channel it down the northern shaft.
That would be one way to do it.
That'd be one way to do it, yeah.
So either way, you believe that the northern shaft was somehow or another collecting microwave energy, and the southern shaft. What would they do with that energy? This is the question.
That's your signal input. That's what enters the King's Chamber and stimulates emission of other photons.
Right. But once this energy is connected,
right.
Once they have it collected,
Right.
How are they How are they using it? How are they utilizing it?
Your guess is as good as mine. I could only imagine if they can dream up how to build this system, how they machined those precision vases, how they built the boxes in the Serapeum, how they created the statues, and knowing that there is so much missing from that culture.
Not only that, but knowing that you have to have something
You have
that
to
you
have
can
something.
use to make this in the first place.
Yes.
Like what kind of material are you using
Yes,
to
so
carry these things?
There's so much missing, and it's kind of like, all right, so you're saying that you use the pyramid to create energy, and with that energy
You do
powered your power tools to build the Great Pyramid.
That doesn't make any sense.
Doesn't
right?
make any sense at
Right.
all, right?
So there was probably some other methods that we're not aware of.
Obviously.
And
I
some
mean, you build any power plant, you're going to have you're going to have generators on site. They're going to wheel them in and fire them
Also,
up.
this is not going to be your first project. You already have some understanding of how this stuff works if you're making something at this scale.
Well, I mean, our industrial development, 200 years of development. Imagine if it's 500 years of development, or
Right.
1,000 years
From now,
from now, right?
Jamie, go back to that image where it showed like a cross section that he said, "Ooh, stop at this one." No, there was one earlier, but that's fine. Either one of them. There was another one that showed like sort of a cross section. That's it. Thank you. So this gives us an understanding of what it would look like originally. There was a gold cap on the top, smooth limestone on the sides. What do you think the function of that gold cap was? Because gold is used in electricity. It's in electronic components. It's a
Right.
great conductor of electricity.
Well, this is where you combine the Tesla's technology and also Freund's laboratory experiments. And in the laboratory, what Freund did is he got a granite slab, a couple of few feet long, and he put it in a hydraulic press in order to test his theory that if igneous rock is put under pressure, it releases electrons. So he wanted to test that, and he set the granite up in his concrete press. Hydraulic press, and then he ran a wire, through an oscilloscope, and then attached it to a copper cap on the other end of the granite. So there has to be some kind of a connection. All right. So you got electrons moving. You got positive charge carriers shooting through the granite, and then they're handshaking at the end with the negative electrons, and everybody does a happy dance and fires up their microwaves. Just kidding. But that is seriously. And then you combine that with Tesla and his proposal to build a system where you can transmit electricity wirelessly without wires through the earth. And he built the Wardenclyffe Tower, which was like a structure that would radiate that power. So that's the inspiration for this image right here.
So the idea would be that this whole thing would be emitting wireless electricity.
Yes.
And so that they would be able to utilize that somehow, like Tesla had theorized.
Tesla.
Well, they actually
Tesla.
implemented it, right, in tests, right?
Yeah. Tesla power, Tesla cars too, probably.
So have you debated anyone about this? Has any Egyptologist or any person who doesn't agree with your theory sat down with you and tried to pick it apart?
I am not a fan of debates myself. I mean, I know it's good theater, and some people are really good at it.
Mm-hmm.
And you were able to demonstrate that the other week. But I'm not a big fan of them. I'm not sure as far as scientists go, or science, or, putting work out there for examination by your peers. I'm not sure that it is helpful to, set up a shouting match or a
I
a
understand what you're
tussle.
saying.
Yeah.
But
I
I'm
mean,
just interested to see what other people have to think about your theory, because this is really fascinating to me. I'm looking at all this and I'm like, wow, this makes so much more sense than having this thing there as just a tomb for a dead guy, which there's not a lot of evidence that that's the case because they've never actually found.
No.
No.
I mean, if you ask me, what was it? Well, Chris, what the hell were you thinking when
What were you
came
thinking,
up? What were
Chris?
you thinking? I mean, and that is actually a key question because, if you're an examiner or if you are pleading you something or somebody is challenging you, what your state of mind was when something happened, an event happened, what was your state of mind at the time is important. And my state of mind at the time was the tomb theory is a dead theory. I don't accept it. The pyramid, because of its design, its features, its precision, it looked like a machine. Perhaps it's a machine. And if it is a machine, how did the machine operate? So that's basically what my state of mind was. And the evidence that I was looking at was evidence of a level of sophistication and a structure that actually demonstrated the highest level, state of the art that civilization or that culture produced.
Or any culture.
Any culture. And it hasn't been replicated since. And
How is that possible?
How is it possible?
The whole thing is so impossible. Like, if you wanted to have the best evidence that we don't know shit,
You've got it right.
you got it right there. It's like, how much do we know about what they knew if they could make that?
Yeah, I know people ask me, say, well, why haven't you built a model? Why? And I was like, you don't understand because I couldn't even afford one of the blocks that goes into the king's chamber, let alone 1,000 of.
And also, like, how much time would it take you to build that? Good Lord.
Not only that, it's like, if you're gonna replicate. I was asked that question when I was in Egypt in 2021, and I was with Hamada Anwar and Dr. Hani Halal, who used to be the Minister of Science and Higher Education. Both extremely good guys, and they are both on the Scam Pyramid mission team. So I had a meeting with them, and I gave my book to Dr. Halal, and Hamada already had one. He'd arranged the meeting. I gave my book to Hani Halal, and I described it briefly. And he asked me a question I never thought I would hear in Egypt, and he says, well, could the Great Pyramid be restored and function as you envisioned that it did? And I was like, I'd pondered that question before, and I'd thought, I can't see that happening. I mean, if you're going to replicate it or create another one, I would do another one, because of the political climate.
Right, of course.
There is so much focus on the Great Pyramid, and everybody who's focused on it is an expert, and most of them have YouTube channels. So you have a hyper focus on that area. I mean, just the a simple thing like, okay, we're going to recover the third pyramid. We're going to restore it. We're going to recover it, and blah blah blah.
People start freaking out.
Yeah, I mean, it was a whole shitstorm that came after that. I mean, they finally killed the project because
I saw. Do you think that it's good they killed the project? I mean, isn't it good to leave that stuff in the state in which we found it?
I think, people with the best of intentions and working with the information that they have can make mistakes. And a lot of times, and I've made them myself, a lot of times it's because I am making decisions not having sufficient information, right? And
Right.
so it's kind of like it was the new chief of the Supreme Council of Antiquities, the chairman of the Supreme Council of Antiquities. And so he had a gentleman who was going to help him restore the third pyramid. And so he goes out and calls a press conference and tells everybody what they're going to do. And then there was a firestorm of criticism that came in, just flooded in. And then finally, I think it was Zahi Hawass who pulled his influence to shut the project down. And then, so they backed up on it. But, if he had touched all the bases, I mean, you just never know, because relationships in any culture, you don't understand them. You don't know who knows who's related to who.
Right.
You got all this activity.
But I think people, rightly so, were upset at the idea of covering that thing, just like they covered up the paws of the Sphinx.
Well, it wasn't
Very controversial, right?
Not necessarily covering it, but
restoring it. But you are covering it, right? Because you're doing it with modern human tools. You're ruining what is left. Because what in the state that it is, it represents the erosion and the earthquakes, the looting of the limestone. This is what it is.
So this is,
But to cover it up with 2024 work seems gross.
Right, and that's what a lot of people think, is that it is not respecting history, or
Right. So if they did that with the Great Pyramid and covered the whole thing,
well, that
would certainly be more possible than building another one.
Yeah.
Right.
Well, you would certainly.
It's a lot easier.
You wouldn't have to quarry as much limestone.
Not even close. So if they did that, let's just imagine a world where people say, "Hey, we're going to do this, but we could always reverse it. We're not going to do any permanent damage to the pyramid, but it's possible to restore it to the exact state and find out if this theory is correct."
Yeah, but how do you do that? I mean, I don't think you would have to have a lot more research and evidence produced than I have produced to convince people to invest so much money.
Right.
Because, I mean, this is a process, okay? The Giza Power Plant and Giza the Tesla connection is a process, right? And I'm pretty much at the end of that process. So you put it out in the universe, and then other people are picking it up, like Ahmed Adli, Ashraf Skabini at the Cairo University.
But let's imagine we enter into a world where people say, you know what, it's better if we know, and there's only one way to know, and it's possible to do. So let's cover that thing the way it was done before. Let's put a gold cap on it. Let's follow the plans as if this is a power plant.
Right, but first you have to qualify, verify all the systems, the subsystems, and their function. Right. And it's complicated.
And would you qualify that? Could it be more possible today through use of AI?
You would need whoever is in control of the AI, who's driving.
Right, but let's look at best case scenario. Let's pretend there's some objective scientists that are not ideologically driven at all, and they're in control of this AI, and they utilize it the exact way we would like it to be utilized.
What I would love is for some PhD student to take on as a dissertation project the acoustic modeling of the interior of the Great Pyramid. get all the dimensions, scan everything, find out all the dimensions, what they are, and then you start to simulate the behavior of the movement of sound within that space. I mean, we have, we're using human instruments to detect resonance and report on the vibrations and how they feel when they hear it, and there's a lot of like magical experiences that are happening, but the magic. I mean, if you've ever read Arthur C. Clarke, it's kind of like sufficiently advanced technology is first seen as magic, right? So if you have an alien race and they have sufficiently advanced technology, you would look at it as magic.
Right.
Our cell phones.
Sure.
If they appeared in our culture 100 years ago,
Magic.
magic.
Yeah.
Yeah. People wouldn't know what to do with them.
And if this culture had something that's not where we are, but 500 years more advanced than us, which is why they were able to create something like that.
Right. I mean,
Looks like magic.
I talk about the recent disclosure by the ODI on the UAPs in here.
Really?
Yeah.
You think they're connected?
As an example of what is possible physically. Because if you consider that, those UAPs can descend from 80,000 feet to sea level in a few seconds, the G-forces that they would pull on a 90-degree turn would be like 1,000 Gs. It would destroy any of our craft and the people inside it, if it was even possible to make such a turn, which it's not. We don't have anything to match it. And then you see how they function, and you see what can we observe on how they are propelled. An F-16, they've got afterburners, and we see these afterburners kick on and fire belching out the back. Those UAPs, they just seem to have some kind of aura around them, and they defeat gravity and move through space in a way that appears like magic. But sufficiently advanced technology would be magical.
Right. Almost less impressive than a cell phone.
Yeah.
Right? Because all it's doing is flying around. A cell phone is sending instantaneous video to the other side of the world.
Well, that little UAP could be doing the same.
Yeah, sure.
But except to other planets.
Right, we just don't see
Or
it.
the mothership, which is
Or
cloaked
Langley.
and we don't see it.
It might be American.
It's all science fiction, right?
I really wonder how much of that stuff is ours. How much of that stuff is black ops projects,
I
like
don't
some
think
stuff that
that-
they've been.
No, I don't.
You don't think
we
so?
have it, no.
You think it's from somewhere else?
I mean, I can't prove where it's from, but if it is from somewhere else, I'd like to follow it home.
You and me both.
I'd like to see the. I'd like to observe
Yeah.
the civilization and the culture that
Right.
created it. Go in the manufacturing plants. Hey, how are you making this? And say, okay, where are you getting your power from? I don't see any train cars carrying tons of coal and belching chimneys out in the distance, right?
Well, if there's a time machine, if there was ever a time machine, I've always said if I could go back to one place, I'd go back to Africa when they were doing that. I'd go to Egypt. I'd see
sure.
What were you doing?
For sure.
What were you doing?
For sure.
How are you guys doing this?
Yeah.
What the hell is going on over here?
Right.
And where did it all go? I mean, I know the burning of the Library of Alexandria, they lost so much.
Right.
And we have no idea what was in there and what knowledge they had preserved.
Right.
So now it's all lost.
Right.
And if you're correct, and if they really did have some sort of a machine that makes electricity that to this day if you want renewable electricity, there you go, kids.
Right.
It's right there. And somehow or another, someone did it 4,500 years ago.
Right.
Like, how?
How?
What did you guys do? And how are you so much more advanced than all the other humans on Earth? So much more.
I'm digging through an article right now of some audio engineers that got access to the Great Pyramid. Like they took in a bunch of high-powered speakers and whatnot. Very first thing this guy recognized here, he says he noticed that there's a very specific, precise frequency when the wind blows across some of the air shafts, and it's F sharp.
Yeah, and that appears in the I think Tom Danley, who was a NASA engineer, and he was on the a team and did acoustic testings inside the Great Pyramid. He measured the frequencies in the King's Chamber and reported that even with all his equipment turned off, the King's Chamber was still vibrating. And he actually...
Go back, Jamie.
Oh, sure.
Look at this right here. It says, ancient Egyptian texts indicate that this F sharp was the resonant harmonic center of planet Earth.
Yes. Yeah, that's the connection. That's the seismic connection. The
F sharp is
vibration.
also, coincidentally, it says in question marks, the tuning reference for the sacred flutes of many North American shamans.
Yeah, the hope is, yeah. So the F sharp is very important. It's also found in human DNA, and there was a Dr. David Deemer who actually mapped the frequencies of DNA.
As an engineer, I will note 16 hertz is just below the human threshold of hearing. The best you can hear is 20.
Interesting. So can dogs hear that? Carl hear that?
They're known for hearing higher. I suppose they could probably hear lower
You'd
too.
be like,
Yeah.
Dad, what is this, Dad?
But around 2003, I was contacted by a very talented physicist. His name is Dustin Carr. You could Google Dustin Carr if you like. He got his PhD at Cornell University, and his thesis dissertation was actually creating a nano guitar.
Whoa.
Yeah. The nano guitar, the strings are just about 100 atoms wide.
Whoa.
And you have to have a tunneling electron microscope to be able to see it. And so, anyway, he contacted me, and I was really impressed with this guy.
How would you strum that guitar?
With a laser light.
Whoa. Whoa. It's 2 microns? Oh, my God. That scale is 2 micron?
Yeah.
Wow, that's bananas.
And so
you used a laser to play this guitar?
You would need, just a very, very subtle laser, which, is like micro heat, expand the strings, and you would get, they would vibrate. But you couldn't hear it, of course.
Right, of course.
No way.
Right, but it exists. So the frequency that's in the Great Chamber is below the threshold for humans to hear.
Yeah. It's
currently
infrasonic, yeah.
Right, but if this machine was running, it would probably be a different frequency, right?
All those frequencies would be playing a part, plus more, I would say. And besides his nano guitar, when we were communicating, Dr. Carr did a model the finite element analysis of the Great Pyramid. And guess what?
What?
16 hertz showed up in that.
Wow. Fascinating.
So,
wow, the whole thing is just so crazy.
It blows your mind,
It really does. There's so many questions and so many places to take it to. The real question is, like, how did they do it? Where did they learn all this stuff from? And did they implement this somewhere else? Is this the only power plant they ever created? The other pyramids, do they have similar function?
I think that fundamentally, perhaps the science of tapping into or harvesting electrons through stimulating movement in the lithosphere was probably known, and that knowledge was advanced and developed.
Right, but if you have with this design, what you believe, the Great Pyramid, how it was used as a power plant, what do you think is going on with the other 2 pyramids that are near it?
Same thing, except they have different interior designs. They're all part of the system.
So it's all connected. All
Right.
three of them are connected somehow.
Yeah.
And have you observed similar situations in those smaller pyramids where it seems like they would be utilized in a similar fashion? Is there shafts and chambers?
No, I just think, if you are considering it as a project, okay, so you design a project, you propose a project, you gather the resources to complete the project, you describe it to your investors. I mean, ultimately, it's about follow the money. How much
Right.
is it going to cost, and what's the return on investment? And so you have, okay, I want to build a great pyramid, and we're going to have all this, we're going to have all this energy, and I'll build another few pyramids around it, and they'll just be tourist attractions. No,
Right.
no. I mean, if you got the whole plateau and the lithosphere beneath it, I mean, Freund said that the lithosphere is actually a giant battery. It can turn into a giant battery if it is stimulated, right?
Right.
And so if you've got that condition, you got all that potential energy under your feet, all you've got to do is shake it a little bit, and just go, hey, send me a few more electrons, and you build a system on the surface. Perhaps you survey the area just like NASA satellites surveyed the area for Freedom and Freund, and you build a pulse generator deep under the Giza Plateau, and you start that system up, and you survey the area, and you look for the hot spots, right, for where the maximum number of electrons are coming through from the lithosphere. And then you say, okay, we'll build a pyramid there, build one there, we'll build one there. Those are your hot spots. You got a hot spot in Texas, right?
Oh, really?
Yeah, Marfa, Texas.
What is it?
It's a town, I think it's...
Oh, no, I know Marfa, but how's it a hot spot?
Marfa lights, have you heard of those?
No.
Yeah, pull up the Marfa lights.
Is it like ball lightning?
No, it's kind of like a light show.
Really?
Yeah.
And
It's very famous.
And it's from the electrons?
Not famous in Elston, obviously.
Well, I know Marfa. I have a friend who has a house in Marfa.
Really?
Yeah, he loves it there. So it's like a kind of an artist community, right?
Probably the energies, right?
Mm-hmm. Like Sedona, right?
Yeah.
That's where all the weirdos go.
Love it. Yeah, I'm one of those weirdos. I can't afford to live there.
Oh, it's a gorgeous place. Sedona's gorgeous.
Gorgeous. Yeah.
So what is this?
I was just like, so there's this interview. I think I'm imagining what they're trying to say here without listening to everything.
So these lights? What's going on with these lights?
What is this?
It's a
Marfa lights?
interview on the Marfa lights.
Oh, okay.
I don't know exactly what it's
So
supposed to show.
when you see those things flying around the sky, what are they? Is that like ball lightning?
Yeah, I mean, it's electrons coming from the Earth and ionizing the air.
It says, according to Judith Bruesk, the Marfa lights of West Texas have been called many names over the years, such as ghost lights, weird lights, strange lights, car lights, mystery lights, or Chianti lights. My favorite place from which to view the lights is a widened shoulder on Highway 90, about 9 miles east of Marfa. The lights are most often reported at distant spots of brightness, distinguishable from branch lights and automotive headlights on 67. So primarily distinguished by their aberrant movements. So these things just sort of fly around.
Mm-hmm.
The first historical record of the Marfa lights was 1883 when a young cowhand, Robert Reed Ellison, saw a flickering light while he was driving cattle through the Paisano Pass and wondered if it was a campfire of the Apache. Other settlers told him they often saw the lights, but when they investigated, they found no ashes or evidence of a campsite. So what is happening again with these lights? How is it? It's electrons going through the Earth?
If you consider Freund's theory, from the Freund effect, it's the release of positive charge carriers from the lithosphere shooting up to the surface. and ionizing the air.
Ah, okay. And so it
Right.
creates a light that way.
So it creates a light that way. Yeah.
Well,
A lot of people have speculated that it could be like piezoelectric activity in quartz-bearing rock, but
it would.
Freud doesn't support that idea, I don't think.
But it would sort of support this theory that if you could find places where that is happening naturally,
Yes.
like Marfa, and you establish the pyramid there.
Right.
You had one other thing that you had just said to me when we took a break, that there was some evidence that you knew about this Dibble-Hancock debate that had come to light.
Oh, yeah, that's it. That was interesting. A fellow researcher, Manu Seyfedeh, he wrote the book Under the Sphinx. He had posted on Facebook a paper that had been published. I think the discussion was the existence of industrial activity during the Ice Age.
Right.
Okay. And so, I talked to him, and he sent me several papers where other studies have been done and that show the same kind of markers that you see in that period of time in the paper that he presented on the podcast.
Mm-hmm.
Everybody should have a chance to fix their mistakes, right? But they are, could you pull them up, Jamie? And we could just go through them. And then they would be on record.
Okay, so what is wrong? So what you're saying is that what he was saying is that the evidence of industrialization only occurs after a specific time in the core samples.
Right, that they weren't, there's no evidence of them in the Ice Age.
And is this lead? What is it in?
Right. So, I mean, this is out of my wheelhouse, so
Right.
I'm not an expert witness.
But this
on
gentleman posted
But
this
I'm
in
just saying
response
I'm
to...
just saying that if there is, another body of evidence or other papers that have been conducted, where research has been conducted, that go further back into the past than the period of time that Dibble's paper deals with, then they should be introduced into the record also.
And how far in the past did these go?
150,000 years.
And how far in the past did the ones that Dibble introduced go?
I think it was between 1,000 BC to 1,000 AD or something. It was just like
A narrow window.
Narrow window. Yeah.
Okay. So did you find it, Jamie?
Well, I don't have Clint's stuff because that was on his computer.
Well, his
Stuff,
paper is the paper that he referenced is in there.
The one that you brought?
Yeah.
Okay. Well, I have what you brought. This is what you have
Is this it?
highlighted.
That's not the one that he presented.
I don't know which one that would be.
It was the 2000. I think it was the 2018 paper.
Yeah, you gave me 5.
Just pull them up.
That's what I just did.
Atmospheric lead and Antarctic ice
Yeah,
during
this-
the
so
last
this is the
climactic
same
cycle?
One. Hold on.
Yeah.
Is that it?
That's one of them. I don't think it's the one that Dibble presented.
But what are the one that you're presenting? The one that you...
The one that Manu sent me. Let's see, which is that one? See, that one, I think it goes back 149,000 years.
So yeah, just send it. Just.
Oh,
so you
this
know.
is the one. Yeah,
Okay.
this is the one. I think that. What date is on that?
I don't know. 2018 maybe.
20. Yeah, I think it's 2018.
Okay.
Right.
So it said the title of this is, for anybody who wants to find it, is Lead Pollution Recorded in Greenland Ice Indicates European Emissions Tracked Plagues, Wars, and Imperial Expansion During Antiquity.
Right.
Okay?
Okay. So if you look up the other papers, they treat a different period of time. And when you go back to the Ice Age, you do find the same kind of evidence.
Is that what this paper is showing?
This is, which one is this the same?
This is the one we were just looking at.
Oh no, this is that short time period.
So this is
1100 BC to 800.
This is the one that
Common
Dibble
Era.
presented then.
Yeah,
Okay. So what's the one that you're presenting?
I'm not presenting.
Okay, but what is the one that you're referencing?
the ones that were sent to me.
Okay, where are those?
They're in the folder, Jamie. Pull them
Okay.
up.
And what is that one called?
That's what I had up.
Okay, go down to the next one. Yeah.
I believe it's this one, right? Where it says highlighted. It says like the Holocene area.
Yeah, I mean,
Okay.
I think they're all kind of similar.
Yeah. The first two. You sent me 5 things. The first 2 are the same. It's just this was highlighted. In it.
Oh,
It's
I
the
see.
only
Yeah,
difference.
okay. Yeah.
Okay. Let's go to that and make it a little bigger.
I sent them to you. They're on there as they were sent to me. So
So it says very low during the Holocene era, probably during the last interglacial and part of the last ice age.
They were very high during the last glacial maximum and at the end of the penultimate. I love that word, penultimate.
I
ice
love
age.
that word, don't you?
It's a great word.
Yeah.
So the concentrations were high of lead during the ice age. It's saying.
Yeah.
So this does counter what he was saying.
Seems to.
Okay.
But I'm not the expert. I mean, I
I understand what you're saying, but this goes far back, but past when he was talking about. So the possibility could be that what Graham was saying might actually have some weight to it. That there was a highly advanced civilization before the Ice Age, and that it went away. And then when you see lead in the future, you're just seeing sort of a re-understanding of this process.
That's one way to put it.
That could be.
Yeah, and it doesn't have to be a really highly advanced civilization like ours. It
Right.
just means that there is industrial activity, whatever that shape or form that takes.
Well, the real fascinating thing is if the Egyptians had figured out how to generate power without any damage to the environment. Which is really wild.
We haven't yet, have we?
No, but if they figured that out with that Great Pyramid, if that process is how they generated electricity, I mean, that's about as green as you're ever going to get.
Mm-hmm.
I mean, pretty amazing.
Yeah. Here's a little factoid for you.
But
Do you know in 2021 they quarried enough coal by weight to build a pyramid 76 times bigger than the Great Pyramid?
wow. Whoa.
So we know how to extract rock,
Yeah.
right?
Yeah, collectively at least.
Yeah.
Yeah. Especially in China, right?
Oh, yeah.
Which is hilarious.
They're very efficient at it.
They're not just that, they're really good at making coal plants.
They're good.
They got hundreds of new ones opening up
Yeah.
while we're over here freaking out.
Yeah.
Anything else before we get out of here? Jamie, you said that there was a couple other slides you thought were really interesting.
Well, I mean, we kind of ended up getting to them. I
Oh,
was
okay.
kind of really curious what that fan was all about, but he described what
Yeah.
got added by someone.
There was one other thing I would like to
Okay.
address, if you don't
Please.
mind. Okay. So the other thing that Dr. Dibble mentioned was when you raised the question about the core drilling,
Right.
right? And Dr. Dibble said that, well, that's been debunked. I'm just paraphrasing now.
Okay.
That's been debunked. And he referenced 2 sources. He referenced Scientists Against Myth and World of Antiquity. Okay? So, this is where, if you don't give enough information, people will fill in the gaps. It's
Right,
like
of course.
you leave a vacuum. Engineers are very well known for leaving all kinds of vacuums. They don't explain everything completely because they assume everybody knows it because they know it, right?
Right.
And so it's the simplest thing. And basically, Scientists Against Myth, they sent me their paper on the methods that they used, which contradicted my methods. And what they did is they got these photographs, 2-dimensional photographs of the Petri core, and they rejected the method that I used, which was just a simple string or cotton thread.
With magnification.
with magnification and with the artifact in my hand. So you've got best evidence in your hand and against evidence second-hand taken with photographs. So what's wrong? What is the problem with that? And when I saw what method they use, I didn't take it seriously. Perhaps I should, and then we won't be here talking about it. But I didn't take it seriously, and it's like it kind of failed on its face just after the first 2 pages. Plus, it was very insulting and mocking, right? Mm-hmm. Not very professional. And but basically, what they did is they took a 2D photograph of a 3D cone. Okay, I want to show you 2 things. This is a flat blank, and this is a cone. Mm-hmm. Okay? So aerospace manufacturing engineers know all about how cones are made, and they know how to measure them, and they know how to transmit geometric data to the customer, right? Our customers would never accept a 2D photograph of a 3D object as evidence of geometric accuracy or precision. I mean, a 3D camera with, like a scanner or something like that, but just a simple
Two-dimensional photo.
Two-dimensional. It won't work.
Right, too limited.
Too limited. But what happens to the evidence when you take a 2D photograph? I'll show you. You have a corruption of the evidence right away. What happens with a 2D photograph taking a 3D object? You can go through these series of cones that are made. This is a cone that has horizontal lines around it, right? Mm-hmm. And you can see that they're horizontal. Mm-hmm. So you can assume, okay, I took a 2D photograph of this, okay? I took a 2D photograph of that, mm-hmm. and then I brought it into my computer, but there are some things that happen to the arc length. The arc length on the original, if you take a 2D photograph, you are using the chord length as the arc length.
You got all that on camera, Jamie? Is it on both cameras? Or the other one pick it up? Oh, okay.
Right. But there's another problem with it, and it's not just geometry. Well, it ultimately is geometry, but it's more involved with how the eye works and how a camera functions, and that's the lens. And basically what you're doing is you're capturing an image of a cone, and if you focus your camera here, right, mm-hmm. the lines here curve that way, the lines down here curve this way.
Okay.
Right? So you take those and you lay them out flat, you've got corrupted evidence. You project those images onto a cone in the computer, and this is what happens. You've got a bunch of wavy lines. Mm. Did you get that? See
Which
that?
indicates that it's a spiral.
No, it doesn't. This is not to prove that it's a spiral. This is to prove that the evidence that they have produced is not the best evidence.
Right, because it's only two-dimensional.
Because right.
To really get to refute your evidence, they should look at the thing and measure it,
right,
accurately scan it.
But it's
too limited.
It also describes the state of mind of the investigators who are working on this, and that is they are driving to a conclusion that is directly opposite to mine. So they're not acting in good faith. If you read a scientific paper or if you are working on a scientific project, if you're in school or if you're anywhere. And so you prepare your report, you publish your report, you describe the methods that you use and the tools that you use, how you did it, and then you publish your results. I did that. And then somebody comes along behind you and they say, well, I want to see that for myself. That's what you call falsification process, where a science, it has any theory, it has to be falsifiable.
Mm-hmm.
So if they can find anything wrong with what you did, then they have to follow the same steps you did,
Right.
to the letter.
Right. But they didn't do that. Clearly.
They didn't do that.
Clearly.
They
And also, they didn't have access to the actual physical object itself.
It doesn't indicate that they did. They were
which is
just
the only way you could really test
They were
it.
just drawing down photographs from the internet.
So they were just trying to debunk it,
Exactly.
and they were doing, and what they're doing is silly.
But then you have a college professor who scoops up all that research, and they become cited sources in their work.
Well, he probably was just respecting their work and thinking that your work is one of those alternative guys that's not a part of the system, not a part of the academic system.
Yeah.
And
Oh,
and so he just
yeah.
and he obviously he works with seeds and things along those lines. So that's his
Right.
his
Yeah.
area of archaeology. So he trusts the other
Yeah.
experts.
Yeah. I'm not saying that. I'm not saying that what he said is his own.
Right. You're just saying that the
invention.
sources are very
I'm just
biased.
saying that. I mean, he was certainly well schooled, and he had the answers to
Mm-hmm.
some of these mysteries, right? And he had been given information, and pretty much he reeled it out when the question was raised.
The other thing that I thought of after the fact, and we actually kind of covered it, but I never connected the dots, was that one of the things that we were talking about when we were talking about Göbekli Tepe. That Göbekli Tepe was created by these people that didn't need agriculture because the place they lived was so bountiful.
Yeah.
But what if they just didn't? What if agriculture to them wasn't plants? What if agriculture was animal agriculture and they fed their animals with wild plants? If the wild plants were in such abundance that they could just go out and chop down the wild plants and use them to feed their animals, that's still agriculture, but it's not plant agriculture.
Yeah,
Right? So that's the difference. I forgot that while it was happening, and then afterwards I was like, why didn't I connect those dots? Because Göbekli Tepe, no one is disputing the time period of it. It's 11,000 years ago, right? That's when it was covered intentionally, 11,000
Right.
years ago. So no one's disputing that, but that puts it into the term of pre-agriculture. And so what he was saying was that maybe where they lived was so bountiful with food that they didn't need agriculture at the time.
Right.
Possible. But also, are we only thinking of agriculture as plant agriculture? And do we have to grow plants in an agricultural setting to feed animals? Well, doesn't that entirely depend on how we're raising these animals? Because if these animals are free-ranging and you have an enormous area, then no.
All right.
Then you could harvest them out free-ranging. You could have agriculture in terms of animals, and you could have these animals that you're farming. You're just farming them with wild plants. And if you could do that for Göbekli Tepe, which is what they're saying, at least they're saying that either they just hunted all the animals that were around them. There were so many animals around them, they could hunt them very easily to feed everybody, so they'd have enough resources to build this thing. Or maybe they had some kind of agriculture in terms of animal agriculture, but just hadn't planted things.
Yeah.
Or hadn't had the need to plant things if they're living in such abundance.
Yeah, I don't know. It's a good question, though.
It is a good question.
Yeah.
All of it is good questions.
All
sir.
these
All
good
of it.
questions.
Yes.
Citizens coming forward and raising their hands and saying, "Oh, wait a minute, what about this?"
What about this? And that's what you've done. And listen, I think you've done an amazing job of it. And the way you explained it today, I I really appreciate it. It's great for a person like myself to be able to ask a person like you questions and get to the heart of how this whole thing would work. And I think you laid it out amazingly. It's such a fascinating subject, and so many mysteries and so many questions. And I just want to thank you for putting in so much time and having so much energy of your life dedicated to trying to figure this thing out.
Yeah. No. All right. Can I go take a nap now?
Yes, you can go take a nap. You did great. Tell everybody about your books, though, so they can go get them.
So anyway, we've got...
The first one was...
The Giza Power Plant.
Okay.
Technologies of Ancient Egypt.
And then the newest one... is, what does it say on that one?
Giza, the Tesla connection.
Can they see it from there? Yeah, okay, cool.
Right.
Giza, the Tesla connection.
Yep.
All right. And those are available now.
Acoustical science and harvesting of clean energy.
All right. Well, thank you, sir. I really appreciate you coming here. I really enjoyed it, and it's you're doing a great service.
You should give those to Elon Musk.
Why, he needs them?
Well, if he's going to build electric cars, he's going to need electricity for them.
All right, I'll let him know. All right, thank you.